fundamental thing you should know. And similarly, carbon fiber with any polymer, can you do? You have to see. Because you have to see the thermal mismatch. If the thermal mismatch is more, what happens, as I told, during heating and cooling, one contracts faster, one expands faster. Then what happens? There is a race. Then thermal stress will be there. What happens? The interface becomes weak, and the fiber is the one which carries the load. There won't be an easy transfer of load from the matrix onto the fiber, and all your engineering is zero. That's, you become only a materials engineer, that's all. Because you have only prepared the material, there is no engineering in the material. So this is the fundamental thing you should understand. And as I tell you, the next challenge, as I told you, here is you have got polymer composites, you have got ceramic composites. Ceramic composites, I'll give you another example, very interesting one. Is all of you have seen the coffee cups? What are they made of? Have you at least thought to, at least have you started looking at what is the material it is made of? No, it is aluminum. It is a ceramic. The moment you drop, what happens? You will have paid 5,000 rupees for that dinner set. You don't want to use it, you just pack it and say because it will break. Because of fracture toughness. Remember, ceramics have got very poor toughness. This is how your approach should be. The fracture toughness is less than 10 MPa something. Don't worry about the actual value. Whereas the fracture toughness of metals is as high as 100. Steel, what is the power? Be as tough as steel. What is the power? What do you mean by that? That means be as tough as steel means it has got a very good fracture toughness. So therefore, any dynamic situation, any impact, any dynamic loading, you still prefer steel even today, although it's the age of composite or aluminum. You are not looking at lightweight. Just because lightweight material is there, nobody will play with your automobile body cover and all, because you are looking at impact, because that is where the fundamental. So there people are looking at fibers, aramid fibers. Aramid fibers can withstand more shock. So therefore you have to first look at the application. What is my application? Then go back. And then see what is the combination. How do you look at the combination? This is what I told you have to look at. Combination, looking at a perfect combination of the thermophysical properties of the reinforcement and the matrix. There you are, as simple as that. And as I told, the cooking ware, it's all metal forming, these are all secondary processing, right? So whenever I want a component, probably it can be only single piece casting. It can be what? Hot rolled. You want a sheet. You want to get a sheet. I think all of your automobile, all your body is all what? It's all sheet, right? You say what is the thickness and so on. Those are all MS sheet you are talking about. Now, if you are looking at those sheets I am talking about, what is the procedure you follow? What? Rolling. And then you are talking about the power industry. You are talking about the power industry. What is that you have? These are all wires. How do you get the wire? It is wire drawing. How do you get a raw material for a wire drawing? It is rod. See, it is not just that the subject has been dumped here just to get away with the course. Please understand, this is where the production starts. I want for 10 mm wire. Where do I start? So I start with a rod, get the rod. Yes, how do I get the rod? From the casting billet. I have to do the extrusion. What is that extrusion? It can be hot extrusion. It will be cold extrusion. So it's not so simple, especially for materials, for metals and alloys. These processes are all well proved. That means they are very, very clear about the sheet metal, the cupping, and then all the other processes are perfect for conventional materials. Tooling is a very important aspect. Please understand. Without perfect tooling, I will also comment on the tooling later. So this is what you need to understand, and this is the real challenge. This is the secondary processing. It can be rolling. Why you want to roll? As I want to get the sheet. I want to get a wire. What is that called? Wire drawing. Right? How do you get that wire drawing? From the rods. How do you get the rod? From the extrusion. So extrusion is a very important challenge. And then there are situations now. One very simple example which all of you are aware is today people are spending lakhs of rupees for what? Sports cycle. Have you heard of it? At least it is called all aluminum cycle. Have you at least seen the internet? There is all aluminum cycle. Now what they do is, today's cycles, have you seen what is happening? You have a sheet metal, it is just rolled, and then you always find one weld line, right? It's basically a It is basically rolled and welded, right? If you look at it, it is not a seamless tube. It is not a seamless tube. Right? Today, what people are looking at is a seamless tube. That is the technology people are looking at. Not only here. Have you seen your solar water heaters? Have you seen? You just look at it. Today, now people are now trying to exploit this seamless tubes technology now in India. Now, if you have a tube like this, now what I am referring to your composites or whatever it is. Now, I want to have a tube now. The question is tube bending, number one possibility. Or second possibility is you have tube, one tube, second tube, third tube. What do? You have to join it. What is the technique? Welding. Now, if you start welding a composite material, again you are in trouble. Because what is happening? There is a two-phase material. So what is happening? All your microstructure will change. The thermal stresses will be there. So you start with the hope that you will get the best bicycle frame. But unfortunately, when the frame gets loading, or when the frame is in loading condition, it gives way without your knowledge. Because there is temperature gradient, right? And then thermal stresses, and especially the joint, it fails. So what I am trying to tell you here is, therefore, you have to go back and look at what are all the processes needed. Then you have to look at, and remember, today welding again is not being perfect. And that is one challenge when you talk about a composite material. So welding is one area. People are looking at laser welding, people are looking at conventional tungsten inert gas welding, and so on. But still, you need to be perfect. So this is one thing which you have really it's an open challenge. And people are now today exploiting one new technology called as friction stir welding. What do you mean friction stir welding means? When you start rubbing like this, what happens? Heat is there. So what I am trying to do here is, you have two pieces coming together, one work piece and the other one disc, rotating disc. You have a very high, you have a lot of heat generated during this friction or contact process, and a lot of modeling studies are happening. What should be this contact surface and so on to get that required desired amount of heat into the material. So these are the real challenges. And okay, so what I will try to do is, in this lecture, I will focus on the challenges, what we encountered, how we solved that problem. The presentation what I am going to make here is a hard work of nearly 2.5 years. So this project was given to us by Department of Science and Technology. I am indebted to them, and it is because of the government, central government, we have that facility. So all of you can come and visit my lab, and in fact I am very sure that this is the only facility available in still I am very proud also to tell you that this is the only facility available, and this is a 200-ton capacity. I will show you what are the problems we had. It took us 2 years to come and then come out with a quality product. Okay, so I'll now start my presentation. It goes with basically on what is called as a tribal. So don't worry about the other portion, tribological behavior. So I'll focus more on extrusion and then talk about the tribological aspects later. Okay. So when you talk about the extrusion, first of all, I am now confined from different class of material to finally only metal matrix composites. Okay. In that metal matrix composites, what normally people look at is they look at 3-4 varieties of materials. Number one, automobile. What is the commonly used material? A356. Why A356 means? It is having silicon as a alloying element. It gives more fluidity to the material. So what happens? You can cast intricate shapes. So without fluidity, what happens? What happens? There will be cold checks, and therefore you will not be able to reproduce the what? Intricate complex geometry. Right? So therefore, we are talking about any of the casting, this one, fluidity, that's one popular alloy. That means, so for A356, you can add, as I told, any ceramic, anything you are talking about, don't worry. Second one is aerospace. Suppose somebody is interested in only attacking aerospace. They will go with all of you have heard of duralumin. Right from 8th standard you have studied duralumin. So it is, don't worry about anything else. Just remember aluminum and copper.